Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. We've been waiting for you and we are glad to have you here. And if you're a returning viewer, welcome back once more. We're continuing our series on mensuration, where we'll be talking about finding areas and perimeters of different shapes. In this particular video, we're looking at finding the area and perimeter of parallelogram. Before we begin, if you have not subscribed to our channel, please do. And if you find our contents useful, please ensure you like our contents and drop comments. If you're finding anything odd, we'll respond to all comments. Or if you don't want to say, oh, well done, please do. And before we continue, I also want to give a special shout out to Parallelogram all the way from Gambia. Thank you very much. I see your comments. I see your love. Love is too much. Maybe one day I'll visit Gambia because of you. So if you have seen this video, please just send me a WhatsApp message. I want to actually get to know you. My WhatsApp details are on the bio of this channel. So let's get started. What is area? Just like I've said before, is the space a shape covers measured in square units. And we said for 2D objects or shapes to talk about area, while for 3D shapes talk about total surface area. And we've used this diagram many times, right? You see this square, all those 4 squares inside that big square is just showing the area that the big square covers. It's just a pictorial representation of what area is. So let's get started with parallelogram. What is a parallelogram? It is simply a quadrilateral. When we say quadrilateral, means a shape with 4 sides. In this quadrilateral, both pairs of opposite sides are parallel and equal in length. So you ask yourself, okay, this is like the same thing like rectangle or square, but there's a difference. And you see this difference now. Look at this. Like a normal rectangle or square, this side here is always at 90 degrees to this line, or what people will say orthogonal. Right, is orthogonal to this line at 90 degrees to this line, and this line here too will also be orthogonal to this line. It's not going to be bent basically, but here is bent. But like we said, the opposite sides are parallel, right, and they are equal in length. We've already thought about the first property. Second property is that opposite angles are equal. So the angle at A is equal to the angle at C, and the angle at D is equal to the angle at B. So opposite angles are equal. These 2 guys are equal. These 2 guys are equal. The angles between them. It now says consecutive angles are supplementary. That is, they add up to 180 degrees. Basically, what they're saying is that the angle at D, this place here, this D, plus the angle on that same line A is equal to 180. The angle at B plus the angle at C is equal to 180 degrees. So the angle at A plus D is 180 degrees, angles B plus C is equal to 180 degrees. And the last thing that you see here is that diagonals bisect each other just like a normal rectangle or square, but they are not necessarily equal. In a rectangle or square, the diagonals are always equal. If you check the length of diagonals, do this. So if I do the length of BD, the total length of BD, you see that it's the same thing as the length of AC when it is a rectangle or a square. But for a parallelogram, there is no guarantee that the length AC is equal to the length BD. Although they bisect each other, if you look at this place, see where they meet, the bisect each other. See this now here. You see this 1 1, right, and this 2 2. So they bisect each other, but the lengths, total lengths, are not necessarily equal. This is something you need to hold in your left hand so that you know it's easy to eat shawarma or popcorn. How do we find the area of parallelogram? There are 3 ways basically. I'll introduce 2 here, and we will solve a question, and that question will lead us to the 3rd way of solving the area of a parallelogram. But for a normal parallelogram, where we have the base and the height, it's just simply base times height, like as if we had the normal area of a rectangle. But for a parallelogram without height, we said this is AB sine x. But how do we get by this AB sine x? Let's assume these are heights, right? I know it's not going to be straight. Permit me. So assume that these are perpendicular heights. This is H. So we have a small triangle here, right? So look at this guy here, here, with an angle X. This H here is opposite to the angle X, and this A here is the hypotenuse of the triangle. So basically we have the opposites and we have the hypotenuse. So if I use SOHCAHTOA, what would that align with? Great. So, right? So I will say sine x is equal to, the opposite is h, the hypotenuse is a. So if I cross multiply, my h is equal to a sine x. And we know that the area of a parallelogram is the base, so I think I was making a mistake, times the perpendicular height, which is h. We know the base, we know the height, which is a sine x. If I join these two together, that will give me what? AB sine x. So that's how they came about this formula, right? Note that a and b are the adjacent sides, so this is one side and this is the side adjacent to it, and the x is the angle between those sides. It's not the angle, okay, if it's the angle here, the angle here isn't the angle here, right? But it's not the angle here, it's not the angle here. The angle must be between both sides. This will have been a very good question. So if I give you this side and I give you this angle here, you say, oh, this angle is not in between the two sides. But we said that the angle opposite each other for a parallelogram are equal. So whatever angle is here would be the same value as here. Nice. This is example. It says that the area of a parallelogram is 513 centimeters square and the height is 19 centimeters. Calculate the base. This is from WAEC 1992. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So we know that the area of a parallelogram is base times height, and we're given the area to be 513 centimeters square, and we're given the height to be 19 centimeters. So if I substitute, that will be 513 is equal to b times 19, and if I divide both sides by 19 will cancel 19. So 513 divided by 19, and that will give it 27. So the base is equal to 27 centimeters. That will be option C. Let's see if we're correct. Great. Example 2 then says that PQRS is a parallelogram with area 50 centimeters square. So this is P, this Q, this R, this S. Great. And the side PQ is 10 centimeters. Which side PQ? So this length here is 10 centimeters. That is the base of the parallelogram. T is a point on RS. So this point T. And TF is the altitude of the triangle TPQ. It's also the triangle TPQ, but it's also the height of the parallelogram, right? Because you can say it's orthogonal. Find TF, basically find the height. I want you to pause the video and try this out yourself. Welcome back. I hope you're able to see that it's very, very simple, even though they put so much English inside. Let's solve it together. We know that the area of a parallelogram is base times height. We're given the area to be 50 centimeters square, and we're told the side PQ, which is the base, is 10 centimeter. Then we should find the TF, which is basically the height. This is basically what they give you. So if I substitute, that will be 50 is equal to 10 times h, and if I divide both sides by 10, my h is equal to 5 centimeter, and that will be option E. Let's see if we're correct. Great. Example 3 says that we should calculate the area of a parallelogram whose diagonals are of length 8 centimeter and 12 centimeter, and they intersect at an angle 135 degrees. I want you to pause the video and try this out yourself. Welcome back. I know that you might have used the area formula and say AB sine theta, but that is wrong. That's because AB are the sides adjacent to each other. They're not the diagonals. What they give us is the diagonals and the angle the diagonals intersect at. So let's look at it together. So let's say these are parallelogram. Forgive my parallelogram, is not fine, but this is one diagonal, this is another diagonal. It now says that the angle that they intersect at is 130. So this place here is 135 degrees because they intersect here and they also intersect here, which is 135 degrees. This is the two places where they intersect basically. So the angle they make here, same angle they make here. By the time we reach angle in a line, you see that the angle here is also the same as the angle here, but I mean we have not reached it. But the angle on a straight line is 180 degrees. So that means that this angle here, you know, this is a straight line. If this is 135, this will be what? 180 minus 135 degrees, which will be 45 degrees. And it's the same thing here, because this is a straight line. The angle here is 135. This one here too would be 45, because that 180 minus 135. Okay, let me also say that this place here, this line here, is the one that is 12 centimeter, and this line is one that is 8 centimeter. You agree with me that diagonals bisect each other? So at this point, say from here to here is 6, from here to here is 6, from here to here is 4, from here to here is 4, just like we said. So if I break this part apart, this upper part, this will be something like this. If I break this down part, this will be something like this. If I break this side, this will be something like this. If I break out this side, this will be something like this. Great. So from here to here, since this is bisecting each other, this will be 4, and this side there will be 12 divided by 2, which is 6, right? And this angle here is 45 degrees. This side here, the angle here will be 135 degrees. This length here will be 4 centimeter. This length here will be, so let me just put centimeter. This side there will be 6 centimeter. This side there is 6 centimeter. This side there is 4 centimeter. The angle between them is 45 degrees. This side there will be 4 centimeter. This side there will be 6 centimeter. The angle here will be 135 degrees. So you can see these two are similar and these two are similar. So if I find the area of this one, I can multiply by 2, and if I find the area of this one, I can multiply by 2. So the area of this guy, remember, this is a triangle with 2 sides and 1 angle. So how do we say we'll find that? We said the area in that case will be half AB sine theta. You can go back to the video on area of triangles if you are finding this hard to reconcile. So this will be half times 4 times 6 times sine theta, right? So that will be 0.5 times 4 times 6 times theta is 135 degrees. So let me just replace it and say this is 135 degrees. So times sine 135 degrees. That gave me 8.485 centimeters square. So let's also find the area of this one. So this would be half AB sine theta, which would be half times 6 times 4 times sine 45 degrees. So this would be 0.5 times 4 times 6 times sine 45 degrees. And this also gave me 8.485 centimeters square. So basically sine 135 degrees, something as sine 45 degrees. You can check that out. So now that we have this, I know that each of these guys have an area of 8.485. So I could just say the total area would just be 4 times 8.485. So if I multiply this by 4, that will give me 33.94 centimeters squared, which is option E. So basically, it might not be nice for you to be breaking apart an exam and be finding the area of each of them, then adding apart. By the time I sat down to look at this very well, I found out that there is a common formula for the area, and I checked it and it's correct. So the area of the parallelogram, if I are given the diagonals, will be half times the length of the first diagonal times the length of the second diagonal times the angle between the diagonals. So that will be half d1 times d2 times sine theta. So if we wanted to do this, that will be half times 8 times 12 times sine 135 degrees. So this 2 here 1, 2 here 4. So this will be 4 times 12 times sine 135 degrees. So we also add 33.94 centimeters squared. So this is another way of finding is the easiest way. Just take d1 times d2 sine theta, then multiply by half. So this is the third way to actually find the area of a parallelogram if you are given the diagonals. Let's see if our answer is correct. Great. This example says that in the diagram PQST is a parallelogram. PR is a straight line. So let's see. This is P, this is Q, this is S and C. Great. So this place will also be 8. PR is a straight line. Where is PR? PR, this entire line is a straight line, right? CS is 8 centimeter. SM, which is the height, is 6 centimeter. And the area of the triangle PRS is equal to 36 centimeters. So this is a very big triangle. The area is 36 centimeters squared. Find QR. I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So if this place is 8 centimeter, this side is also 8 centimeter, right? And we're given the area of the triangle, this big triangle. So the area of triangle PSR is equal to 36 centimeters squared. And we're told that the height of the triangle is 6 centimeter. We know that the area of a triangle is half base times height, right? So this 36 is equal to half times base times 6, right? 2 here 1, 2 here 3. So the base will be equal to 36 divided by 3, which is 12 centimeters. So that means that this base here is 12 centimeter, and we're trying to find the length of QR. But we know that the length PR, which is the full length, is equal to the length PQ plus the length QR. The entire length is 12, length PQ is 8, we don't know length QR. So I can make QR of the formula. So length QR will just be equal to 12 minus 8, which is equal to 4 centimeter. So the answer for this is 4 centimeter. Let's see if we're correct. Great. Example 5 now says that which of the following properties is or are common to parallelograms and rectangles? First, all angles are right angles. Is that correct? No. We know that for parallelograms, there are times that it bends, right? Parallelograms bend. So as far as it bends, it cannot make a 90 degrees with the other side. So what do I mean? These are parallelogram and it's bending here. It's not going to make a 90 degrees now. These are degrees that are 90 degrees. 90 degrees is something like this, right? And that is what is characteristic of a rectangle. So while it is true for a rectangle, it's not true for a parallelogram. So this is out. So the second one is diagonals are equal. Is that true? No. While it is true for rectangles, diagonals are equal, we say that for parallelograms, the diagonals are not always equal. Remember that previous example, we had 8 centimeter and 12 centimeter as diagonals. So you see that it is not true. So the option 2 is out. The third one says that the opposite sides are equal and parallel. Is that true of a parallelogram and a rectangle? Yes, it's true. So these are our answer. The opposite sides are equal and parallel. So our answer is option E. Great. Like we said before, perimeter is the total distance around the edge of a shape, and perimeter of a parallelogram is the total length of its 4 sides. So side 1 plus side 2 plus side 3 plus side 4. And if you see this guy, if your side is A and B, your perimeter will just be 2 open brackets A plus B, synonymous to the perimeter of a rectangle. So let's say an example. It says that the perimeter of a rectangle is 40 centimeter. If one side is 15 centimeter, find the length of the adjacent side. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So perimeter is 2 open brackets A plus B. Perimeter is 48 open bracket 2 open bracket. One of the sides is 15 plus the other side is B. So if I divide this side by 2, this 24 is equal to 15 plus B, and B will just be equal to 24 minus 15. So that will be equal to 9 centimeters. So the other side is basically 9 centimeters long. Great. And with this, we've come to the end of area and perimeter of parallelogram. So I know I didn't do an example where I had to do AB sin theta, but I mean it's find A, B, and sin theta. You find the angle. So look out for more questions on parallelograms that have area, that have perimeter. I mean anything, the different types, diagonals, 2 sides and an angle, and base and heights, and solve questions on it. The only way you can get better is when you solve more questions. I'm just showing you the steps on how to solve it, but the real work lies in your hands. I'll see you guys in the next video. Bye for now.